LandExplorer, powered by OmicsSoft team, allows you to generate a chart and see how your gene of interest is expressed in cancer using sample sets coming from different public sources like TCGA and more, all processed in the same pipeline. Here, ICAM1 is more expressed in lung cancer compared to low-grade glioma. Or you can use this to generate a chart and see how your gene of interest is expressed in the cancer you're interested in. Now, the key advantage of this is that if a group were to process all these sample sets on their own, it would take them a tremendous amount of time and resources, as opposed to using LandExplorer, where expression data for hundreds of those samples are all in one location. Let's say that you are studying colon cancer, and you find that ICAM1 could be an interesting target or biomarker. A question you may ask is, how is ICAM1 expressed in cancer? This is where LandExplorer can help. To see how ICAM1 is expressed in cancer, you can simply search for a gene of interest under the Genes and Chemicals tab and click on the hyperlink under the Symbols column. This will open up the Gene View page in your browser, which has additional information about your gene of interest. Here, many users like you focus on the section that has OmicsSoft. As I mentioned earlier, OmicsSoft is the group that's processing all sorts of public data coming from sources like Blueprint, CCLE, GTEx, TCGA, and many more. Here, we will select TCGA. This launches LandExplorer, which is a nice integration between IP and OmicsSoft, where we have data for tens of those samples all processed using the same pipeline. Here, the expression of ICAM1 is displayed across different types of cancers, including our cancer of interest, colon cancer. Since you want to focus on colon cancer, you can use the filters on the left-hand side to filter for tumor type. Here, we're going to go ahead and check none, select colon cancer, and then click apply. Once we do this, everything will be removed except for colon cancer. On the right-hand side, you can see what type of tissues the data is coming from. Now, instead of just looking at the expression of ICAM1, you want to look at specific expression levels for ICAM1. You can do that by generating a custom query. So we're going to go ahead and go to Custom, select RNA-seq expression, search for our gene of interest, select Categorize, enter our expression levels of interest, click Apply to Visible Samples Only, name our query, and then click OK. Once we do this, our query will appear here. We can select our query filters to filter for those samples with low, medium, and high expression of ICAM1. We can separate these expression groups by changing our grouping from tumor type to our new custom query. Now you can see samples are based on expression levels of ICAM1. If you want to know what these samples are, you can select them by drawing a square. Once you do this, a table will appear down here that will tell you the TCGA numbers for the samples, give you copy number variation, and expression values as well. Many times, users like you will download this data from LandExplorer to Excel by using this button. They will then use information to make their own custom charts or for downstream applications. Looking at this table, you may wonder, how does expression of your gene of interest correlate with copy number? You can use LandExplorer to identify copy number variations. To look at copy number variations, we're going to go ahead and change our view from Gene FPKM to Integration Copy Number Variation to RNA-seq Expression. The x-axis values in this view represent the log2 ratio. A ratio of about 0 corresponds to no change in copy number variation. A positive ratio indicates copy number gain, while a negative ratio corresponds with copy number lost. Clicking on individual samples, represented by dots on the plot, opens up a table with additional details like copy number status. You can always export this table by clicking on this button here.